Hello friends, I welcome you all to this lecture on C programming. In the previous lecture, I've discussed with you about 1D array, and in fact, I've told you that how to initialize or declare an array. But now it is the correct time to solve some problems so that we can understand the working as well as syntax of array in better sense. So the first problem is vector addition. Now, you know that whenever, let's take a three-dimensional domain, and in this I am having a vector. Now this vector, you all know, as this is a three-dimensional domain, so it must be having, let's say the vector is A, so this must be having three components, that is A0, A1 and A2. How to write it? So this is A0i, A1j and A2k. What are A0, A1, A2? They are nothing but the components of this vector in the x, y and z plane or axis. So what we can do is, so if you look here, this is nothing but AY, this is AX and this length is AZ. Okay. So that is how we represent a vector graphically. Now, if I have to supply the same vector in a program, then what I have to do? Nothing. I know this is a three-dimensional. So this is having three components. So let's say A, and what are these? They are nothing but A0, A1 and A2. Okay. Now in this, imagine another vector, B vector. Now this must be having component, let's say B0, B1 and B2, as we are in three dimension. Again the same thing we can also do. What? So this length will be by, this is bx and this one will be bz, that is b0, b1 and b2. Same thing we can also write here, three components, b0, b1 and b2. Now friends, we all know that if I am interested in adding these, then what I have to do? If I simply say A3 plus B3 and assign it to C3, then this won't be working. Why? Reason being, this operator works on, or this is defined for operating on two integers, two float, isn't it? This is basically a binary operator requiring two numbers. But here A and B are not numbers, they are array. So how to add two arrays? So in general what we do, we add the zeroth element and store it in the zeroth place of C, that is A0 plus B0. Take the first element and store the first B1 and A1 addition here. Likewise, C2, add A2 plus B2. So if we do this, then the elements will be transferred. How to do this? Again, a very simple thing, because we are moving sequentially, so we have to run a loop. The similar thing we can also do for subtraction. So in place of addition, we will be writing minus. That's it. Okay. So addition and subtraction will be done like this. So first we should have some array and array elements. Then we will be running a loop. And if you want to generalize this, let's say ith element of A, if I add the ith element of B with it, then what should I get? The ith element of C. In the Einstein's notation, Ci is normally written as Ai plus Bi. That's it. So if it is C0, so it must be A0, B0. If it is C1, it is A1, B1 and so on. So that is how you add or subtract two vectors. Now when it comes to vector product, so here you are having two things: dot product, which is also called as scalar product, and cross product, which is vector product. The Let's say I'm having this vector A dotted with vector B, and I'm having components. Then how do I perform it? I will be doing it as A0 B0 plus A1 B1 plus A2 B2, isn't it? So we are summing up the indices. So in Einstein's notation, A vector dot B vector, how do we write it? We write like AI Bi sigma I will be, let's say, starting from 0 to 2. So it is A0 B0 plus A1 B1 plus A2 B2. And if we are in, let's say, proper tensor form, so tensor form is nothing but AI Bj, where del Ij will be having a value 1 when I is same as j, otherwise it will be 0. That's it. So both the way we can proceed, either this or this. We have to do the same thing. So let us head to the editor and try to understand what we have learned so far. So let us make one integer type array A having three elements in it, and let's say it is I. Let us take problem first. Let's say my first vector A vector is 2I plus 3j plus 4k, and my second vector is I minus j plus 3k. Okay, so it is 2I 3j 4k. So what I have to do? I have to pass the array elements as 2 3 4 for the first, and for the second it is 1 minus 1 and 3. So 2 3 4 1 minus 1 and 3. Okay, so it is 2 3 4 are the array elements for array A, and for array B again 3. This 3 is basically optional here because we are initializing the array right just in the same declaration statement only. So it is basically 1 minus 1 and 3. So it is 1 minus 1 and 3. Now these are two arrays. So now you know that when we add two vectors, so the resultant will be vector. When we subtract two vectors, the resultant will be a vector. So let's declare add array with the same number of elements as that of A and B. Similarly, sub with the same number of elements as A and B. Now, what I have to do, Now, what I have to do is I have to run a loop for, here I have to declare this also, int I0, I less than 3, I plus plus, and inside the loop what I have to do? I have to add what? Add the ith element of A to the ith element of B, and this result I will be storing in C. So this will be assigned to add. So add is the name of the variable to the ith element of A. That's it. We have done it. Now to print the subtract, so sub ith element, just I'll copy this, and in place of addition I will be writing subtraction. That's it. Friends, the task is over. Now what I have to do? I have to print the result. So for printing, again I will be using this loop. So first let's say I am printing the addition part. So here I will be writing printf %d comma, and this is add and I. So if I do like this, then the result will be printed in the same line, and that will be difficult to understand. So what I'll do, I'll write one comma here. Similarly, we can do for subtraction. So here, instead of add, I will be writing the name, that is sub. Let me check it once more. Yes, it is sub. And once this is over, then what I have to do, I have to bring the cursor to the new line. So new line, so that it becomes, or it looks nice. So let us run it. So here, look, what is the vector A? It is 2, 3, 4. Vector B is 1, minus 1, 3. So if I add 2 to 1, so it will be giving me 3. 3 plus minus 1 will be 2. And 4 plus 7, 3 will be 7. So this is your addition part. Likewise, for subtraction, it is 2 minus 1 is 1. 3 minus of minus 1 will be 4. And 4 minus 3 will be 1. So friends, in this way, you can very easily add and subtract two vectors. Now comes the important part, that is dot product. And you know that dot product is nothing but a scalar product. So the output will be a number, single number. So that scalar, that means doesn't have any dimensions or components or numbers, simple single number will be there. So what we'll be using is, let's say, as the a and b are integers, so I can use it. So let's say dot. Dot is basically, or to be more precise, dot product is that particular scalar quantity where we have to supply the result of dot product and initialize it with 0. Why? Because if you look here closely, let us say it is 0, then I will be adding that to 0, then this to that addition, then this to that addition. So the starting will be 0, then 0 plus a naught b naught, then a naught b naught plus a1 b1, then to this a naught b naught plus a1 b1, I will be adding the last term, that is a2 b2. So here, let us, here inside, so I'll saying dot and then dot product and assigning it what, let us copy this, and instead of minus I'll be writing multiplication, that's it, and I will be transferring that to this one, so plus. So this is nothing but dot product assign dot product plus ai. And then finally what I'll be doing is I will be printing the result here. Dot product is, to new line, let us bring this, will be equal to percentage d comma dot in product. Close the statement. Now if you run it, then your answer will be 11. Yes. Why? Because 2 times 1 is 2, 3 times minus 1 is minus 3. So 2 minus 3 will become minus 1 plus 4 times 3, that is 12. So minus 1 plus 12 will become 11. So the answer is 11. So in this way you can manipulate or work with one-dimensional arrays. And this is a beautiful example of one-dimensional array. So here what you have done is, you have simply created a one-dimensional array. What is a one-dimensional array? An array which is having single index, that is what we call as one-dimensional array, a single rack. And if we are having multiple racks, that means if we are having this, so this rack is a single rack. Only one index will be capable of moving or fetching the element or supplying the element. But what if we are having this or this? Then if I am having element 5 here in this place, then only one index will not be sufficient, because I have to tell that in which row the element is and in what column. So therefore this type of array is what we call as a two-dimensional array, because here if we have to move in row, let's say I am using index I, for column I am using index j. So this element So this is 0, 1, 2, this is 0, 1, 2. So where this element is lying right now, it is row number 1 and column number 1. So this information I have to supply. Then only that particular element will be fetched. Okay, so this we will be discussing in detail in the coming lectures, but for the time being, I think you now know how to add, subtract and have a dot product of two vectors. In the next lecture, what we will be doing is, sorry, in the next lecture, we'll be learning about cross product, which is nothing but vector product. A very, very important thing, and a very important thing not only from the point of view of that one-dimensional arrays, but from the point of view of mathematics also. Because if you look this thing, and if you look this thing here, we are using only one loop. What if I have to use two loops? If you have to use two loops, then you have to follow this concept of chronicle delta. This is what we call as chronicle delta. This I will tell you in detail when we move to the cross product. So before cross, I will be doing dot product again, but with the help of this formula. So in this lecture, till this point only. In the next lecture, we will be learning more on one-dimensional arrays. Thank you very much for watching it.